Good morning. I'm Leonardo Lima, and I will present the Black Sea Reanalysis system in the framework of the Copernicus Marine Service. As an introduction, ocean reanalyses are becoming increasingly important to reconstruct and provide an overview of the ocean state from the past to the present day. The Black Sea Reanalysis system is produced using an advanced data simulation method to combine the best available observations with a state-of-the-art ocean general circulation model. The system provides a four-dimensional time series of the ocean state to study ocean dynamics and run-level sources and impacts of ocean variability in the Black Sea. The objective is to ensure the best representation of the Black Sea circulation and its thermoline structure, as well as to provide more accurate ocean monitor indicators that can help to understand the Black Sea response to climate change. This slide summarizes the main configurations. The main configurations of the Black Sea Reanalysis system. So, for instance, the model component is NEMO version 3.6. The ocean model NEMO is fostered by ERA 5 atmospheric forcing. Then, the system assimilates sea level anomaly along track observations from CMAS, temperature and salinity in situ observations from both CMAS and CDataNet. And finally, we apply a SST relaxation using the SST L4 product from Siemens as well. Between the upgrades in the data simulation scheme, we have new empirical orthogonal functions to estimate the background error covariances in the B matrix. And also, we have applied a new model-based mean dynamic topography to compute the model equivalent sea level anomaly data simulation. Now I will show some results. For instance, this slide shows results of SST validation. In the left, horizontal maps show a predominance of positive SST bias. In addition, the Black Sea reanalysis presents the lowest root mean square deviation in spring, whereas the highest values are reached in summer and autumn. For instance, the values exceeds 0.75 Celsius degree along the upwelly region in the Turkish coast. In this region, we believe that overestimated surface winds from the atmospheric dataset, in our case ERA 5, may intensify the upwell events in summer and autumn. Following half-molar diagrams of the temperature bias and root mean square deviation reveal a clear seasonal pattern such that the values are low in winter and higher in summer. The bottom diagrams shows that for saline, both bias and root mean square deviation remain low over time. We also prepared vertical profiles of root mean square deviation and bias for different subdomains in the Black Sea. Each color represents a different subdomain. For instance, the root mean square deviation is relatively higher in the northwestern region, the dark blue region. This region is under the influence of the Danube River. For instance, the Black Sea reanalysis represent with less quality the salinity above 20 meters. In the light blue region, the absence of the Azov Sea may have negatively impacted the temperature representation. And finally, in the green region, the model does not represent well the influence of salt waters from the Mediterranean Sea in such a way the salinity root mean square deviation profile shows higher values in the layer between 60 and 100 meters. Now, I show some validations for sea level anomaly. For instance, in the top, spatial maps reveal the largest values of root mean square deviation closer to shelf areas, which are related to the mesoscale activity along the ring current. Now, time series of temperature present a continuous warming in the layer between 25 and 150 meters. In this layer, there is the presence of the Black Sea cold intermediate layer, the seal. In response, the seal almost disappeared in recent years. For instance, after 2008, the formation in the presence of the seal is observed only in 2012 and to a lesser extent in 2017. As final considerations, the system has produced very accurate estimates which make it suitable for understanding the Black Sea state from the recent past years, allowing to obtain better climate inputs to the sea. But in order to improve the quality of the Black Sea reanalysis, new developments in ocean modeling and data simulation are still important. And sustaining the Black Sea Ocean Observing System is crucial. This presentation summarizes the article published by Lima et al. In 2021. So the title is Climate Signals in the Black Sea from a Multi-Decadal and Resolving Reanalysis. Also, I list other publications based on the Black Sea reanalysis system, like the ones from the Siemens Ocean State Reports. And finally, in this year, it's important to say that new ocean monitor indicators will be delivered on the Siemens website. So these ocean monitor indicators are based on the Black Sea heat content, and another one based on the ring current index. Thank you for the attention.